Alright, ladies and gentlemen, today we are looking at the distributive property. Now I know this is something you guys definitely looked at last year, but we're going to take a look at it again, and we're going to definitely look at some more complex examples than you may have in the past. We're going to use this in combination with other stuff we already know how to do, and we'll build on it a little bit as the chapter goes on too. So the property basically says this: if we have multiplication in front of parentheses, and either addition or subtraction inside the parentheses, what we can do, let's say we wanted to bypass the order of operations. Okay, so order of operations says we need to do b plus c or minus c, whichever symbol happens to be in there first. But suppose for some reason we wanted to bypass the order of operations, maybe to make our expression look a little better, or turn it into a form that we could solve if we're using it to solve an equation. The way that we can do that is by distributing the multiplication to both terms inside the parentheses. We keep that addition or subtraction symbol the same, keep it whatever we was, and we multiply a by both terms that were inside of the parentheses. Now, this also works if you have more than two terms inside your parentheses. You could have 3 terms, 4 terms, 5 terms. As long as they're being added and subtracted, you can completely distribute that a to each of those individual terms, okay, whatever's on the outside. Just for your information, the reason we know it works, here's a really good visual example of why this works. Okay, so suppose we had a rectangle that we split up into 2 smaller rectangles. Okay, the width is A, and the width of this smaller rectangle is B, and the width of the larger rectangle is B, and the smaller one, the width is C. So what you could do is you could think about this: how would you calculate the area of the full rectangle, so the one that's here? Well, what you would do is you could do one of two things. You could either first add B to C, do that first, and then take whatever that result was and multiply by A. Right? You could do that. Okay? Or you could take the value of the area of those individual rectangles, with this one being A times B and this one being A times C, and you could add them up. Okay, so you could take individual areas and add them together. Look at what you have. You have the distributive property. If you add first and then multiply, that's with parentheses. If you multiply first and then add, as long as you multiply that A by both B and C, that's the other side of the distributive property. So that's a pretty cool way of looking at it. So we're going to take a look at a variety of examples here. First ones that we're going to take a look at just involve numbers. Okay? So when you're first starting off with this, even if you've done it last year or you feel like you're really good at it, I would strongly suggest that you first write out what this looks like right after you distribute whatever's on the outside of your parentheses. Okay, so keep your 2x and your 3 in that format and just show that you're distributing the 3. Then do the multiplication. 3 times 2x, we can multiply the 3 and the 2 and get 6. And 3 times 3 is 9. We can't put those together in any way, so we're just done. Why don't you guys try B on your own, pause, and then come back when you're done. Alright, so I'm assuming you've done that by now, and you should have had 2 times 4x plus 2 times 5 is what you get after you distribute, and we get 8x plus 10. Now those are very, very, very basic examples, okay? Examples can definitely get more complicated. Now we're going to look at what happens when we multiply variables. We haven't really looked at multiplying variables yet, but we're going to take a look at it right now. So the distributive property simply looks like this: 2x times 3x minus 2x times 4. You don't have to show all the moving around of the terms that you're doing, but like in that first term, that 2x times 3x, we're going to multiply the 2 and the 3 and get 6. And we're still going to have x times x left. Well, you could leave it x times x, but a better way of writing that x times x would just be x squared. Over here, in the second term, we're just going to multiply the 2 and the 4 and get 8. and we just have our x left over. We cannot combine those terms. Even though one's an x squared and one's an x, we can't combine those. We're going to find out a little bit later on this week, or maybe next week, in one of our next couple lessons, why we can't combine those. Try B again on your own, pause, and then come back. I'm assuming you've done that. Again, I'm still writing out the distributive property. I'm not going to force you to do this, but again, I would say when you're first starting off, it's probably a very good habit to get into. And then after you get comfortable with it, you are going to want to drop that intermediate step and just jump straight to your answer. And that's a good thing. Okay, so you should get 20x squared plus 8x. The cool thing about this is that we can do this with more complicated stuff too, with division being involved and with subtraction being involved. You have to be careful here though. A lot of people make a mistake on these subtraction ones because they just see the 2 on the outside. But remember, we shouldn't be just distributing a 2, because what could we change that minus 2 into? Well, we could change it into plus a negative 2. Okay, so if you think about it as plus negative 2, really what you should be doing is you should be distributing a negative 2. Okay, so my 3 stays the same, and then I get plus negative 2 times 2, or just, if you prefer, just minus 2. And then I get minus negative 2 times 2x. Okay, so I distributed that negative 2 to both of those terms. Here I'm going to get a minus 4 plus negative 4 is the same thing as minus 4. And over here I'm going to get a plus 4x. I can combine my like terms. 3 minus 4 is negative 1. Okay, if you don't want to show this intermediate step, you don't have to. As long as you can get to your answer, that seems fine. But definitely make sure that when you see subtraction before parentheses and you're distributing, that you make sure you're distributing a negative. Okay, so try B on your own, pause, and then come back and I'll show you what that answer is. All right, I'm assuming you've done that. So this time I'm not going to change it to plus and negative, and I'm going to show what this can look like if you don't show that intermediate step. So I get 4, negative 3 times 2x is minus 6x, and negative 3 times positive 4 is minus 12. Combining my numbers together, the ones that I can, the 4 and the minus 12, I get negative 8 minus 6x. Okay, so hopefully you got that one right. Last little bit, and this is actually much easier than it looks. As it turns out, the distributive property works for division too. The reason it works for division is because dividing all 3 terms by 2, remember we can assume that these are in parentheses. This is the same thing as multiplying by 1/2. Okay, so now we could distribute that 1/2. But you don't even have to think about it that way. This is one way to think about it. Another way to think about it is that you're dividing each of your individual terms by the 2. So I don't particularly care how you look at it. I actually think about it in the way that's in green. I prefer to think about it that way, but that's just my personal preference. It's entirely up to you how you think about it. But what I've got up here in blue is another good way of thinking about it, and it kind of shows you that's why it works, because really division is just another form of multiplication. Okay, so simplifying this green version or the blue version, doesn't really matter. I get x plus, whoops, apparently I opened the App Store, sorry. I get x plus 2y minus 3. And I'd get the same thing if I distributed the 1/2 up there too. So try B on your own, come back and check, and then we'll be good. All right, I'm assuming you've done that. So again, thinking about it as 4x divided by 4, that's just x. 8y divided by 4, that's 2y. Last one's a bit tricky. 2 over 4 is the same thing as 1/2. So you could write 1/2 z, or maybe plus 0.5z if you wanted. All those would be good. I know that was kind of a lot to cram in. Sorry, the video was a little bit long this time around. Sorry about opening up the App Store randomly. But that's all we got for this one. Try some practice problems, take a concept quiz. Good luck.